This is the full build video for the power out alarm. It's a cheap power out alarm, power out sensing alarm that you can get on eBay. 2 of them for $12 or 4 of them for $16. Excuse me, eBay. Amazon has them. I'm sure they're all over the place, but that's the prices for Amazon. You can buy devices that will functionally work about the same way for around $35 a piece. That's what I found. So basically what we've done here is we've modified this existing alarm to power up a ESP32 when the mains power is been removed. So it uses a 9-volt battery. This unit has a optocoupler, which is what senses that the mains power has been removed. It senses that and switches, uses a transistor and a MOSFET to power up a 3.3 volt power regulator, which in turn powers the ESP32 as well as the alarm sensing board. Now in this application, the switch just turns the audible alarm off. So all this circuitry over here is for the audible alarm, and it does pull quite a bit of current using the 9-volt as the way that it the way that it was designed originally. It's pulling about 3 watts. With the 3.3 regulated and the audible alarm on, it's pulling around 600 milliwatts. And then with the audible alarm off, it draws around 83. Now, yes, what did I say? 600 milliwatts with the audible alarm on, and then that's 185 milliamps. And then with the audible alarm off, it's 83 milliamps. This is all this information is in the write-up that I did. Basically, one of the first steps you're going to do is identify the optocoupler. The dot on the optocoupler's number is pin number 1. Pin number 2, that's on the high voltage side. So if you flip this little board over, you'll see when I've put a liquid electrical tape on all the high voltage connections. But this is pin number 1, pin number 2 of the optocoupler, and then pin number 3 and pin number 4 is what we're sensing. Pin number 3 is the ground, and that's already connected to the board. So we're identifying the ground off the 9-volt battery. Both of these units that I had red colored leads, so I just put a little black Sharpie on that, identifying the ground. And then it's easier to not get confused when you're moving these wires around. So the optocoupler senses when mains power is removed. It then uses a transistor and a MOSFET to power up this regulator, which then provides 3.3 volts to the audible siren through this switch. So if I power this up right now, you should get a siren, and then I can turn it off. It's also powering the ESP32. Now I did put a resistor in line for the Piezo because it was still too loud, even at 3.3 volts to my liking. I, in my application, are not going to be using the audible portion of that, but you still want to have it in the off position, because even if it's on and the wires are removed, it's still running the circuitry and going to be a lot more power draw. So in this second unit that I built, I clocked the power regulator and flipped it over. The LED right here will shine through this window when it's all up. So it's going to give me a little visual indication that the unit's powered up. I'll still have it switched in the off position, but this whole board will not be powered at the time. It's just powering the regulator and the ESP32, which is going to save a lot of power requirements. So building the circuitry, on the write-up that I have that's on GitHub, you'll see some nice images of that, how I created that, soldered that component. So we've got 3 resistors, we've got the MOSFET and the transistor. You have a couple choices you can use, just a standard, the larger transistor, or excuse me, the larger MOSFET. I decided to go with the smaller one just for the smaller footprint. These are obviously easier, way easier to source, and price-wise, they're not too much difference if you spend some time and research. Both of these I got on AliExpress for like 30-40 cents a piece. And then these were very economically sourced on AliExpress also, I think, as well as the ESP32 boards. I've gotten a lot of stuff from AliExpress. Just takes a little bit of time. So I did a little prototype board with all those components, worked out all the resistance figures to get everything to work properly. And yeah, works pretty well. We'll see. I've also, if you go to the GitHub, there's a wiring diagram and more information on how to create this and build it, as well as the code for the ESP32. You'll find all that information on GitHub. Thank you.